Hello everyone, this is Amir from Audio Science Review. A few people had requested that I do some cable reviews, and fortunately I've done some. So I thought I cover this interesting high-end cable by AudioQuest called the AudioQuest Wind. Got it over here. This is an unusual cable. It actually has a battery. 72 volts. A bunch of little cells in series generates 72 volts, and that voltage then goes to one side of the connector, and then the wire goes through the cable but doesn't connect to anything at the other end. What it generates is unknown because you need to complete a circuit for current to flow, and if you have a battery where one end isn't connected to the other end, no current flows and no electricity flows, and they've got a patent on this, so it is unique, but whether it does something or not, we'll have to measure. At any rate, the review's online, but let's go through it in detail. Reference is always a free cable. You just grab in my box of freebie cables I've gotten over the years and plug one in, and I'll call it a generic free cable. Somebody asked what it was, and I looked at it. It actually was made by Hitachi. Apparently it got a cult following, oxygen-free and what have you. But I think it's only costs like $30 or something. You can still buy it in Japan. So maybe it's a good generic cable, but $30. I forgot to say that, tell you the cost of this cable. This cable for a pair at 1 meter is $2,300. No, that's not a typo. $2,300 for two of these. By the way, the owner donated this to me. That's why I still have it. So let's go down. We want to compare to see if this cable does something better than a generic cable. So let's go ahead and do that. I've got my audio precision generating a 2-volt sine wave at 1 kilohertz, roughly 1 kilohertz. Audio precision has a sine wave generator that's world class. It is extremely low distortion, and you can see this on the right, where it only has a tiny little blip in here at 2 kilohertz that's down minus 155 dB or so. Remember, threshold of hearing is minus 115, 115. So on the left over here, this is where the best case hearing, where you're in a dead silent room at 1 kilohertz or 2 kilohertz, you can hear. So we're way down here. We do see a little blip in here, which is 60 hertz mains interference hum, if you will. Not an issue, not audible, because it's well below our threshold of hearing. I'll come back to this a little later. So this is our 1 meter generic cable. Let's plug in the AudioQuest Wind. What do we see? Nothing's changed on the right-hand side of this graph. On the left side, something's a little change in here. We actually have a new spike we didn't have. Kind of curious. It's supposed to make things better. It seems to have made it worse. And this 60 hertz mains has actually gone up, gotten worse. Let's ignore that for now. Everything else is the same. Voltage is the same. Distortion's the same. Same frequency down to, I don't know, 6 decimal, 5 decimal places is still the same. So it absolutely, positively did not do anything. So I thought I'd play a cruel joke on this DBS thing. If the design is around, and this is directional, obviously, because as I said, the cable connects at one end and not the other to this battery thing. So you would reason that if it does something in that direction, if you reversed it, it should be worse or it loses benefit. Well, it does nothing. Same 2.01 volts, same distortion, same everything, same new spikes we didn't have before, same distortion, everything. No difference whatsoever. So at this point, you can be confident that this DBS thing does nothing useful whatsoever with respect to noise floor, with respect to distortion, with respect to amplitude, frequency. Nothing's changed in that regard with respect to DBS. Now, tonality is determined by frequency response. If a cable has a filter in it that rolls off the highs, some cables do have passive components in there. that would change tonality. So let's measure that. And when I say measure, I mean really, really, really measure. We go up to 200 kilohertz. This is 10 times higher than our best case, more or less best case high frequency. Most of us in my age are way down here, well below 20 kilohertz. But let's go up to 200 kilohertz. Let's figure that these wealthy audiophiles that probably are later in age and to have money to buy this kind of thing, maybe they have preserved their hearing and they can hear up to 200 kilohertz. Here we see that the audio precision, when it's in its loopback mode, which means that just a relay turns on with no cable essentially, and a generic cable and AudioQuest Wind, all three of them land on top of each other in a very zoomed vertical scale of only 1 dB above, 1 dB below. So these are really tiny, tiny variations in here. Threshold of audibility is probably half a dB here, but still, there's just no difference. So we have proven beyond a shadow of doubt that this thing cannot increase bass or lower bass or increase treble or increase mid-range. It cannot change the tonality of any tone between 10 Hz and 200 kilohertz. It absolutely cannot. It is impossible for it to do that, because if it can do it, it would show up in this test. Very sensitive test. But let's go back on this noise issue. That bothered me. Let's plug in the generic cable and then also the AudioQuest Wind cable, but turn off our generator, sine wave generator. So the analyzer now is just reading the noise that's from the analyzer itself and whatever may be generated by the cable. And we see curiously that the generic cable has lower noise in here, around 60 hertz and around 180 hertz. Now 180 hertz is not a random thing. It's 3 times the frequency of 60 hertz. And it could be an odd harmonic of that 60 hertz. So I wanted to figure out what the source of this was, and as I was testing, I noticed if I moved this cable around, that this measurement changed. So I thought, well, I wonder if it's picking up noise from the rest of the equipment that's in here. There are a lot of sources of interference. These cables are supposed to be shielded, but there's no 100% shielding. So I thought I'd make a test case for a more exaggerated case where we can see the difference. And what I did was that I took an AC transformer. These are little adapters that come with some of your audio gear. And I plugged in an extension cord to the end of this so I could then move this around as a wand. And I brought this next to the generic cable, and I brought it then next to the AudioQuest Wind cable to see whether they pick up noise interference inductively, magnetically through the air. So I'm not making any physical connection to anything. I'm literally just bringing that plastic case near a cable. That transformer in there is generating a magnetic field, so it can induce, if you will, the mains spectrum onto the cable if it's not perfectly shielded. So I've got the previous 2 graphs there in dashed lines. But when I bring in that cable, obviously, let's focus on a generic cable in blue. We do induce more noise. As I said, there's no such thing as a perfect isolation, if you will, from that kind of magnetic field that's quite strong. And so we go from this dashed line at the bottom to 10 or 15 dB higher noise for the generic cable in blue. But look at what happens with AudioQuest Wind, which is the dashed red, just by itself sitting in the air, to when I bring the transformer close to it. It shoots way the heck up there. Look at how much higher the amplitude is. We're not talking, we're gone up to 100 dB from original, which was around minus 145 or so. So some 50 to 60 decibels worth of mains has been picked up by this $2,400 cable. It's supposed to be shielded. If it's shielded properly, it shouldn't do this at all. It should be as good as the generic cable. And you might say, why are all these other things in there? Well, the power company sends you a sine wave, 60 hertz, but that sine wave actually has distortion. And those distortions have harmonics in them, and those harmonics show up as this series of peaks that you see. Now, any power supply that you use in your audio equipment, first thing it does, filters all this stuff once it converts it to DC. So don't worry about this being an issue with your equipment. But in here, for this cable, it's picking up noise. I mean, it's a simple test. So the question is, how is the company, making this claim down here that it has a 6-layer noise dissipation system, a 6-layer? You think, wow, it should be much better than my generic cable. Yet we're finding the exact opposite thing. I said, whoa, maybe they're right. Well, if they're right, they should make a measurement like this and post it. It's not hard. It's not. What was difficult about making this measurement? Anybody could make this measurement and show it. Do they show this? Absolutely not. We can go to their website and you see all the claims in here. You see any measurements in here? You do not. You see any graphs? You do not. You see any specs? You do not. Nothing in here other than 14 paragraphs about wind and how the role wind has played in ancient Greek and what have you. Spare me the story. I want to know, if you said it lowers noise, where's the lowered noise? Doesn't exist. But people say, well, these are trivial tests. You're only testing with one tone. Music has many tones. And so fine, let's measure that. Nice thing about testing cables is that the volume doesn't change, so we don't have to level match anything. And I used a very high performance system for testing. I used my RME 80i2 FS DAC, which is a $1,000 professional DAC. People say, if somebody wants to say that's no good, RME equipment is used to produce the music you listen to. So if you think that's no good, your music's no good. And I hooked it up to a Topping A90 as an audio amplifier, which is a world-class instrument grade headphone amplifier. And then I hooked it up to a $1,000 Mastrop Ether CX headphone. And I did an A/B test. There was absolutely no difference whatsoever that I could detect. And I went back and forth. Now, somebody buys a $2,400 cable, takes it home, as I've explained in previous videos. When you hook it up and you listen and pay attention to what you're hearing, you will hear new detail. But I guarantee you that new detail was not new. It was always there. And once that placebo effect wears off, it will sound just like it always did. And that's one of the reasons you find high-end audiophiles constantly searching for one tweak after the other. That initial effect wears off, and then they go get some new, and that false set of, it sounds better, lasts a while, and then that goes away, and then the next tweak and next tweak. But that's another topic. So anyway, our conclusion here is simple. Objectively, this cable is worse. It's got one simple job to do. Take a signal from this point, take it to the other point, and don't pick up noise while you do that. We need a shielded cable because its distance is relatively long as circuits go. And it could act like an antenna and pick things up. And indeed, this one is a mains antenna. So, or whatever is around it, it is happy to pick those up. Now, fortunately, the threshold of hearing is very high in low frequencies. That's why you're not going to hear hum or noise with this in practice. But it is generating them objectively, and that's bad. That's bad in a $10 cable, and certainly bad at this price point. Okay, so hope you liked this video. In the comments, tell me if you want more of these controversial videos, or you want me to go back to doing some more plane reviews, and I've got a bunch of new products to test, and I could be doing those as well as these. Okay, see you in the next video. Bye-bye.